These are the two trigonometric addition identities, and they may seem rather obscure and illogical. You may have wondered how they even work. This video is going to show you a really cool proof to derive these identities, and it's super intuitive. Like a good start to a trigonometric problem, let's begin with a triangle with a hypotenuse of 1. To find the length of the side adjacent to angle A, we can use cosine. Since cosine is adjacent over hypotenuse, and the hypotenuse is 1, we know that the length is just cosine of A. In similar fashion, to find the length of the side opposite to A, we can use sine, which is opposite over hypotenuse. You may recognize this from the unit circle. Now, let's place this triangle inside of a rectangle, where each corner of the triangle is touching a side of the rectangle. And let's call this angle down here B. Now, we're going to try to solve for all the sides of the rectangle. First, we know that this whole angle here is A plus B. This makes 90 degrees, or a right angle, with another angle that we can visualize in pink. So now, if we want to find this angle on the top in the purple, we can add it to the pink angle. This should give us 90 degrees because it's in a right triangle whose right angle has the other 90 degrees. To solve for the purple angle, we can subtract 90 degrees from both sides, and we know that it must be A plus B degrees. Now that we know the purple angle, let's solve for the left side of the rectangle. We know that sine of A plus B is opposite over hypotenuse. Since the hypotenuse of this triangle is 1, the length of the opposite side must equal the sine of A plus B. Cosine of A plus B is the adjacent side over the hypotenuse, or 1. So that's the length of this top section. Great. Now let's look at the bottom. Sine of B is the opposite over hypotenuse, or cosine of A. So the length of the opposite, n, is cosine of A times sine of B. Now, what's the adjacent side? Using cosine of B, we know that the length of the adjacent side, n, must be cosine of A times cosine of B. Nice. Now, we just need to solve for 2 more lengths. But first, we need to solve for some more angles. Over here, we know that this turquoise angle must make 90 degrees with A, since they're in the same right triangle. So this total angle here is 90 minus A plus B degrees, which simplifies to 90 plus B degrees. We know that a straight line has 180 degrees, so that means this little angle down here must be the difference between 180 and the orange angle, or 90 minus B. And of course, since we are in a right triangle, that means this angle plus that bottom angle equals 90, so the bottom angle must be B. Alright, now for the sides. In this triangle, the sine of B is the length of the opposite, n, over the hypotenuse, sine of A. So n, or the length of the side on the right, is sine of A times sine of B. And the length of the bottom can be found with cosine of B. That's sine of A times cosine of B. There we go. We just found all the sides. Great job following along and hanging in there. Now, here's where all the magic happens and how we find those addition identities. If we just look at the lengths that make up the sides of the rectangle, we see that sine of A plus B has the same length, or is equal to, cosine of A times sine of B plus sine of A times cosine of B. That's trigonometric addition identity number 1. Now, what about cosine of A plus B? Notice that that is this length over here. To find that, we can subtract sine of A times sine of B from cosine of A times cosine of B. And boom, just like that, you have both addition identities. Was that cool or what? If you like this type of video, let me know in the comments so I can make more. And be sure to subscribe. Thank you for watching.